The major drawback associated with the Klein-Gordon equation was the occurrence of a negative energy, and was actually resulted from the act of squaring the relativistic expression for energy. And from this act, it was inevitable that you have to take the square root of the final expression for energy eigenvalue that eventually gives rise to a negative energy state. And the position probability density is written in terms of this energy, so that it was again inevitable that there occur a negative position probability density. To get around this difficulty, what Dirac has done is that he ascertained that in no part of the derivation of his equation there must occur the act of squaring the relativistic expression for energy. If it is not done, then definitely the equation that he is going to propose will be a first order equation in space as well as time. And he argued that such a first order equation in space as well as time will give rise to a positive definite position probability density, and it was resulted also, and there resulted or emerged new concepts or new things in physics that has no classical counterpart at all. And these achievements include the prediction of spin possessed by microscopic particles, the magnetic moment of electron. We know that electron is a charged particle, and even if it is a free particle, it will be rotating around its own axis, that give rise to a spinning charge which must be associated with a magnetic moment. And this magnetic moment of electron for the first time in physics was introduced by or as a concept or as a byproduct of Dirac's relativistic equation or relativistic wave equation, and the occurrence of particles and the particle in pairs. This is also a concept first of all introduced by Dirac. However, in this theory also, the negative energy persisted, though he has taken utmost care to omit this occurrence of negative energy. The negative energy persisted. That means the occurrence of this negative energy or particles having negative energy is in fact a reality, and he made a reinterpretation in order to go with the concept of these particles having negative energy. This has given rise to a new theory referred to as Hall theory, and there were a lot of experimental facts that supported this Hall theory. We will now move on to the formulation of Dirac equation introduced by Paul Adrien Maurice Dirac in 1920s. Is first of all a first order equation, that is first order in space as well as time, and since it being a first order equation, this gives rise to a positive definite position probability density. This is first order in space as well as first order in time, and it must satisfy the relativistic requirement that the equation must be invariant under Lorentz transformation. There is no difficulty associated with such an equation which is first order in space to satisfy the Lorentz covariance. A first order equation in space will be always satisfying the Lorentz invariance condition. And since for it to be a first order equation that it satisfies the Lorentz covariance, it must be a first order equation in time as well. And once it is first order in time, it will be then definitely satisfying the dynamical postulate in dynamics or mechanics, that by knowing the present situation of the system or state of the system, you will be able to predict the state of the system in the past as well as the state of the system in a future point of time. So the difficulty faced by Klein-Gordon equation that it will not be satisfying the dynamical postulate in mechanics will not be faced by the Dirac equation. Since it's a linear equation, the wave function will be satisfying the superposition principle as well. Now we will be again starting from the relativistic expression for energy to formulate the equation, and that give you a lot of various methods by which the equation can be derived. However, we will be trying a direct mathematical procedure that is somewhat easy to formulate Dirac equation. We have once again the relativistic expression for energy E equal to square root of P square C square plus M square C power 4. He was so sure that at any point of the derivation of this equation, this square root cannot be omitted by squaring the equation. Of course, he required to omit this square root symbol as a mathematical operation by some other procedure. However, in no step this square root act or this act of taking the square root is omitted by squaring the equation. So C can be taken out, C root of P square plus M square C square, and we can replace P by minus IH cross grad the operator format and E by IH cross dou by dou T. This is also consistent with the 4-vector representation. Energy is in fact the fourth component of the momentum 4-vector, as we have seen earlier while we talked about the derivation of the Klein-Gordon equation. Now, how this square root can be omitted? What Dirac has done is that square root is in fact a mathematical operation. Why it can't be omitted? By introducing some new operators that has mathematical nature. And he in fact introduced these operators having four different components, 3 alpha component and 1 beta component, and he argued that these are purely mathematical operators that will be able to replace this square root operation in this equation. That's also a possible act as long as quantum mechanics is concerned, provided you are able to deduce the properties of these operators. He also made this correction as well. He also introduced the properties and qualities and features of these operators. Here onwards, these operators will be referred to as Dirac operators. We will now see the exact way in which the equation can be derived. We take E equal to C root of P square plus M square C power 4, that is C into P square plus M square C square all raised to half. Actually, this is square only. Now E is replaced by IH cross dou by dou T, and this square root can be replaced in the next step. C into P square is replaced by P is minus IH cross dou by dou X plus minus IH cross dou by dou Y plus minus IH cross dou by dou Z, the 3 different components. There is a squaring for this equation. We commit that squaring plus M square C square all raised to half. That is C into minus IH cross can be written as plus H cross by I. Minus I in the numerator is plus I in the denominator. Dou by dou X1 plus H cross by I dou by dou X2 plus H cross by I dou by dou X3. That can be written as a dou by dou X mu, where summation over this index mu is understood, whole square, plus M square C square raised to half. Now what Dirac has done is that this act of taking square root can be replaced by means of 3 different alpha operators, 1 beta operator. These alpha operators are associated with the 3 space-dependent components of the momentum, and beta operator is associated with this rest energy M square C power 4. for the term coming from rest energy, that is m square c square here. Then this operator associated with the rest energy must be different from the operator associated with the momentum square. On the basis of that argument, he introduced three alpha operators associated with momentum and one operator beta associated with the rest energy part, as long as the relativistic free particle is concerned. Later on, we will verify that this alpha and beta are also related to each other without any space or time dependent modification, that this also specify their space and time independence or their exclusive mathematical behavior. Then the equation may be written as IH cross dou by dou t equal to, now H cross by I can be taken out from the first term, from the first three terms. Then this becomes H cross C by I into alpha 1 dou by dou x1 plus alpha 2 dou by dou x2 plus alpha 3 dou by dou x3. How these alpha components come upon each and every term, of course, that is a point for argument. However, the way in which they must occur with different momentum dependent components must be analogous to each other. That is why he has introduced one alpha operator with the x component of momentum, one alpha operator with the y component of momentum, and the third alpha operator with the z component of momentum. And this squaring also, this squaring within this square root is also omitted with the introduction of this alpha operator or alpha as well as beta operators. This also make sure that alpha and beta operators are operators that are independent of space or time coordinator. Space or time coordinate. They have only the role of accounting for this mathematical operations of taking the square within this bracket and taking the square root of this entire quantity within the bracket. So alpha and beta operators are operators that have exclusive mathematical operation as their nature. So H cross C by I into the first component of this equation coming as a bracket corresponding to this bracket with a square is alpha 1 dou by dou x1 plus alpha 2 dou by dou x2 plus alpha 3 dou by dou x3 plus corresponding to this term m square c square. Here we have accounted for a act of square taking square root corresponding to this bracket. Here also we account for that act of square taking square root. M square c square will have a square root, that is mc. MC is also then associated with this new operator, say beta, corresponding to this taking this act of square root. And there is one c outside. C is multiplied to this term, then that becomes beta mc into c, that is beta mc square. Why this kind of an operator, alpha and beta, or an operator having four different components, three alphas and one beta have been introduced, is due to the antilinear or non-linear behavior of this equation, that is square root. We know that square root a square plus b square is not equal to a plus b. However, Dirac required somehow this is equal to a plus b. It's exactly in that manner the relativistic expression for energy occurs. Square root of this is a square and this is b square. If there is a 2ab term, definitely this will be equal to a plus b, and there is no question of introducing new operators. However, there is no such 2ab product term. That is why he had to introduce these operators, say alpha as well as beta. Once these operators are introduced, it's of course needed to Once new operators are introduced, their properties are also needed to be introduced. So there are 4 different new operators: alpha 1, alpha 2, alpha 3 and beta. Their properties are to be then introduced. For that, so far we have taken only the operator part of the equation as IH cross dou by dou t equal to H cross C by I into alpha I dou by dou xi, or you can represent it as a alpha mu dou by dou x mu plus beta mc square. As there are 4 different operators, alpha 1, alpha 2, alpha 3 and beta, the wave function upon which this operator operates should have or must have 4 different components. So psi, the solution to the Dirac equation, must be a 4-component wave function and can be written as psi equal to psi 1, psi 2, psi 3, psi 4. For psi square, that has the meaning of taking the dagger, the product of the dagger of the wave function and the wave function itself, as long as the matrix representation of the wave function is concerned. Then this is equal to psi 1 star, psi 2 star, psi 3 star, psi 4 star, row vector into column vector psi 1, psi 2, psi 3, psi 4. That is psi 1 star psi 1 plus psi 2 star psi 2 plus psi 3 star psi 3 plus psi 4 star psi 4. That is psi 1 square plus psi 2 square plus psi 3 square plus psi 4 square. Or this is equal to summation over I psi I star psi I, that is equal to psi I square. Of course, this is a positive definite parameter and there is no question of occurrence of a negative position probability density. Psi square is nothing other than the position probability density. So, the Dirac equation offers a positive definite position probability density. And that has resulted in solving almost half of the problems faced by the Klein-Gordon equation. Still, there occur the difficulty of going with these operators. Their exact nature needed to be talked about. We will resolve this problem and will identify the exact nature of these operators very shortly. But for the time being, we must make some intuitions and implications about the nature of these operators, though we have already made it. This must be mathematical operators or must have mathematical nature only, and that should account for writing or introducing this kind of a new mathematics, square root of a square plus b square, somehow equal to a plus b. This is purely a mathematical procedure, and for such a procedure, you introduce 3 alpha operators with this component A and a beta operator with this component B that corresponds to the rest mass dependent energy. So components of alpha and beta are such that these equations E and P relationship as necessitated by the relativistic expression must be consistent. Alpha and beta must be consistent with this expression for energy and momentum. And this introduction of alpha and beta must be consistent with the Klein-Gordon equation, as since Klein-Gordon equation is a direct consequence of this relativistic expression for energy. So with the introduction of these operators alpha and beta also, you must be able to obtain the Klein-Gordon equation once you square this equation, that is Dirac equation, that involve these operators alpha and beta. And these alpha beta operators are such that these operators are consistent with the energy momentum expression as well. And of course, these operators alpha and beta must not introduce any hindrance for this equation to satisfy a continuity equation, since it happens to be a dynamical equation of motion, and all dynamical equation of motion must be satisfying a continuity equation, as we have seen it in the case of a Schrodinger's equation, or in the case of a Venturi meter, or in the case of Klein-Gordon equation. In this case also, the Dirac equation must satisfy a continuity equation, and alpha and beta must not produce or put any hindrance in satisfying such a continuity equation. And alpha and beta are such that they must not introduce any hindrance for this relativistic equation to satisfy the Lorentz covariance condition. So alpha and beta must have these properties as well, or these operators alpha and beta are such that they are ensoaked with these ideas. They must not introduce any hindrance for the energy momentum relationship to be satisfied. Once you square this equation, this must produce somehow the Klein-Gordon equation. Alpha and beta must not introduce any hindrance on that. And corresponding to that, alpha and beta must be having some properties, some mathematical nature for these properties as well. It's that properties which we have to identify. And this should not produce any hindrance for the equation to satisfy a continuity equation as well as the Lorentz covariance condition. For that, we once again consider the operator format of this equation. That is, of course, the operator format of the Dirac equation. We will now onwards call this equation as the operator format of the Dirac equation. And once psi is introduced here, then this is the Dirac equation itself. IH cross dou by dou t equal to h cross c by I, alpha 1 dou by dou x1 plus alpha 2 dou by dou x2 plus alpha 3 dou by dou x3 plus beta mc square. Operate this equation on psi, the 4-vector solution for the wave function, that is often referred to as a 4-component spinor. Why it is called spinor? We will find out a justification for this name towards the end of this discussion, and the content is that the Dirac particle is associated with a spin that is equal to half. Since it is having a spin that is half integer, this wave function is often referred to as a spinor. So operate over this 4-component spinor, we get it IH cross dou psi by dou t equal to h cross c by I, alpha I dou by dou xi plus beta mc square operating over c. Now operate this equation, operator format, again upon this one. This actually account for the act of squaring this equation, and once I square this equation, this must be consistent with the Klein-Gordon equation. That is one of the property to be exhibited or satisfied by this operator, say alpha and beta. They must not produce any hindrance on the equation to satisfy the Klein-Gordon equation once you are going to square it. So operate this operator format of Dirac equation upon the Dirac equation, we get IH cross dou by dou t operating over IH cross dou psi by dou t equal to h cross c by I, alpha I dou by dou xi plus beta mc square operating over h cross c by I, alpha I dou by dou xi plus beta mc square psi. Now this is IH cross into IH cross minus I square is minus h cross square dou square psi by dou t square equal to, here there will be a lot of terms. This itself, the first bracket itself contains 4 different terms. So there will be a total of 4 into 4 equal to 16 different terms. However, some of them will be identical. Say for example, h cross c by I into h cross c by I. This 3 into 3, 9 different terms will be consisting of 3 square terms and 6 interproduct terms. The first term will be, say, h cross c by I into h cross c by I. So h cross square c square by I square into alpha 1 dou by dou x1 into alpha 1 dou by dou x1. That is alpha 1 square dou square by dou xi square. And there will be square term corresponding to this dou by dou x2 and dou by dou x3. Of course, there will be interproduct term dou by dou x1 into dou by dou x2 plus alpha 1 alpha 3 dou by dou x1 into dou by dou x3. So 3 out of the 9 different terms will be square terms. Alpha 1 square dou square by dou x1 square plus alpha 2 square dou square by dou x2 square plus alpha 3 square dou square by dou x3 square plus the remaining 6 will be interproducted, and they can also be clubbed as there will be alpha 1 dou by dou x1 into alpha 2 dou by dou x2 plus the converse term alpha 2 dou by dou x2 into alpha 1 dou by dou x1, and they needed to be clubbed, say corresponding to this product. This one produces you alpha 1 dou by dou x1 into alpha 2 dou by dou x2 plus, and this term into this one produces you alpha 2 dou by dou x2 into alpha 1 dou by dou x1. So they can be combined separately. So the first term will be h cross c by I into h cross c by I, make it h cross square c square by I square into alpha 1 square dou square by dou x1 square plus alpha 2 square dou square by dou x2 square plus alpha 3 square dou square by dou x3 square plus now this inner product term alpha 1 dou by dou x1 into alpha 2 dou by dou x2. Alpha 1 and alpha 2 are independent of space and time coordinates. So alpha operators will be commuting with this space dependent as well as time dependent operators dou by dou x1 and dou by dou x2. And we have to identify whether they commute among themselves. I am not sure about the fact that alpha 1 and alpha 2 are commuting. So I cannot combine this alpha 1 alpha 2 term in the product term and alpha 2 alpha 1 in the product term. So I'll have to write them separately. I have written it here alpha 1 alpha 2 dou by dou x1 dou by dou x2 plus the converse term alpha 2. This is the term that I obtain when I when I open this bracket using this term, and I will have to open this second bracket using this term also. There will be 3 different terms corresponding to that. The first term will be alpha 2 alpha 1 dou by dou x2 dou by dou x1. Dou by dou x1 and dou by dou x2 are commuting. So plus alpha 2 alpha 1 dou by dou x2 dou by dou x1 plus etc. The remaining terms also will be there. I have written only 1, 2, 3 terms. There will be 6 more terms, and 2 terms out of the remaining 6 will be the square terms corresponding to alpha 2 dou by dou x2 and alpha 3 dou by dou x3, and the remaining 4 will be in the product terms. Now I'll be having a term, say h cross c by I into this bracket into beta mc square. So mc square into h cross c by I is common, that is h cross c square into c cube m by I into this product term will be alpha 1 dou by dou x1 beta, that is alpha 1 beta dou by dou x1 plus alpha 2 dou by dou x2 beta mc square will be there, etc. And the converse term will be beta mc square into alpha 1 dou by dou x1. That also will have a common constant term h cross c cube m by I. So that is overall taken out, and all these different terms are written. There will be a total of 3 plus 3, 6 different terms, and their nature will be alpha 1 beta dou by dou x1 plus the converse term will be beta alpha 1 dou by dou x1 plus etc. So all these 6 different terms are introduced here. Plus now there will be one more term, beta mc square into beta mc square, that is beta square m square c power 4 operating over psi. Now we divide this equation throughout by h cross square c square. Then this becomes h cross square vanishes minus 1 by c square dou square psi by dou t square equal to, here we can replace these additions by means of a summation over I alpha I square. H cross square c square is used for division, so h cross square c square vanishes. There will be I square in the denominator. I square in the denominator is minus 1. That is minus summation over I alpha I square dou square by dou xi square. So these square terms are introduced here. In terms of this index, say I varies from 1 to 3, plus this interproduct term will have h cross square c square by I square, h cross square c square vanishes, minus is written here, so I'll have a bracket here, actually a bracket here, alpha j plus alpha j alpha I, and here we have introduced this index, say ij. Actually there are two different terms, alpha 1 alpha 2 plus alpha 2 alpha 1, two term products. So once you introduce I and j, there will be alpha 1 alpha 2 plus alpha 2 alpha 1. However, I and j has to vary from 1 to 3. So there is a chance for duplication of this term. To get around this duplication, I have introduced a 2 in the denominator. That is, there must be alpha 1 alpha 2 corresponding to I equal to 1 and j equal to 2. And ij varies will give you alpha 2 alpha 1. If you take I2 and J1, that's also a possibility, then these terms will be duplicated. So to get around this duplication, I have introduced a 2 in the denominator. So this bracket is now over. Now this term h cross square c square is used for dividing it. So there will be c and h cross come to the denominator. H cross c cube m by I becomes, say, cm by h cross I. That is mc by ih cross, summation over I from 1 to 3, alpha I beta dou by dou xi. So this terms becomes alpha I beta plus beta alpha I dou by dou xi operating over psi. And here also you can have this operation over psi. Operation over psi is understood here also. Plus m square c power 4 by h cross square c square. Make it, say, m square c square by h cross square beta square psi. For rearranging again, minus 1 by c square dou square psi by dou t square equal to minus summation over I, j and k alpha I alpha j plus alpha j alpha I by 2 dou square psi by dou xi dou xj plus mc by ih cross, this term mc by ih cross, summation over I from 1 to 3 alpha I beta plus beta alpha I dou by dou xi dou psi by dou xi plus m square c square by h cross square beta square psi. Now you can identify this bracket as the anti-commutator of these two operators out of the three different alpha operators, and all these possibilities are being covered. That is, alpha 1 alpha 2 plus alpha 2 alpha 1 is the corresponding to ij equal to 1 2, alpha 2 alpha 3 alpha 3 alpha 2 is the corresponding to ij equal to 2 and 3 respectively, and all the remaining possibilities are also inserted here. And this is also an anti-commutator, alpha I beta plus beta alpha I, that is anti-commutator alpha I beta, alpha I comma beta. And this also include all the three different possibilities of this anti-commutator, alpha 1 beta anti-commutator, alpha 2 beta anti-commutator, and alpha 3 beta anti-commutator, plus m square c square by h cross square beta square psi. So this act of squaring the Dirac equation is now over, and we now argue that this is consistent with the Klein and Gordon equation, that is D'Alembert psi equal to m square c square by h cross square psi. you have this term m square c square by h cross square psi, and the time dependent part of dLm version minus 1 by c square rho square psi by dou t square. What we require is on the left side, what is required is this term, say del square psi term only. Then del square psi minus 1 by c square rho square psi by dou t square equal to m square c square by h cross square psi. And such a representation will be consistent with the plane coordinate equation. And del square term is there on the right side, that is minus summation dou square psi by dou x psi dou xj, that is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square, corresponding to I equal to 1, I equal to 2 and I equal to 3. And of course there will be dou square psi by dou x dou y, dou square psi by dou y dou z. However, such terms are not there in the plane coordinate equation. That necessitate, and once you take this minus term to the left side, it will be modified as a plus term. So we require only dou square psi by dou xi square plus dou square psi by dou y square plus dou square psi by dou z square, and the remaining terms in this inner product are not required. Also, this term is not at all required. That necessitates some properties for this alpha and beta operators. And here also we require only m square c square by h cross square psi, that necessitates beta square to be equal to 1. That gives the first property of this operator, say beta. Beta square is equal to 1. It must be an idempotent operator, and this anti-commutator must be equal to 0. Anti-commutator alpha I beta should be equal to 0. Then this term will not be there. And in this term, we require these terms when I equal to j, and when I is different from j, these are not required, because there is no term dou square by dou x dou y or dou square by dou y dou z. These inner product square terms are not there in the plane coordinate equation. So this must be equal to 0 when I is different from j. That happens when anti-commutator alpha I alpha j is equal to 0. And these terms are required when I and j are equal. When I and j are equal and is equal to 1, then this is alpha 1 square plus alpha 1 square by 2. That is 2 alpha 1 square by 2. That is alpha 1 square. And when I and j equal to 2, that will be, this term will be alpha 2 square dou square by dou y square. When these are equal and is equal to 3, then this is alpha 3 square dou square by dou x3 square or dou z square. That necessitate alpha square alpha I square equal to alpha j square equal to alpha k square equal to 1. And when I is different from j, anti-commutator alpha I alpha j must be equal to 0. So we now make a comparison with the plane coordinate equation. We obtain alpha I alpha j plus alpha j alpha I by 2 equal to Kronecker ij. When I and j are equal, this is equal to 1. And when I is different from j, this is equal to 0. That is, when I is different from j, this is only anti-commutator alpha I alpha j equal to 0. Or alpha I alpha j plus alpha j alpha I equal to 2 times Kronecker ij. Or anti-commutator alpha I alpha j equal to 2 times Kronecker ij. Now suppose I is equal to j, then this is anti-commutator alpha I alpha I. That is alpha I square plus alpha I plus alpha I, that is alpha I square. That is equal to 2 times, when I is equal to j, Kronecker is 1. So 2 alpha I square is equal to 2 into Kronecker ij, that has a value that's equal to 1. That means alpha I square is equal to 1. That is the first property of alpha I. And when alpha I is different from I is different from j, then Kronecker has a value that is equal to 0. That means anti-commutator alpha I alpha j when I is specifically different from j is equal to 0. So alpha I are operators, they anti-commute among their components, and when alpha I is multiplied with itself, then that give you a value which is equal to 1. Similarly, for beta, we have seen from the last term that beta square must be equal to 1. So beta square is also equal to 1, and from this term, say this one, there is no question of such a term, dou by dou xi term or dou by dou x or dou by dou y or dou by dou z term in plane Gordon equation. So this anti-commutator must be equal to 0. So alpha I beta plus beta alpha I is also equal to 0. So not only alpha i's anti-commute among themselves, but also they do anti-commute with this fourth operator beta. For all the Dirac operators are anti-commuting among themselves. Alpha I beta plus beta alpha I equal to 0. That is anti-commutator alpha I beta equal to 0. Or alpha I beta is equal to minus beta alpha I. When this is equal to plus beta alpha I, we say that these are commuting. When this is equal to minus beta I, these are anti-commuting. So this single equation is sufficient to give all the properties of the Dirac operators. They are anti-commuting among themselves and they are all idempotent operators. Now we will see some more features of these Dirac operators based on our idea on the very derivation of the Dirac equation or the very nature by which these operators are introduced, are also based on the idea that we have obtained from this mathematical formulation. All these operators, alpha and beta, are independent of space and time coordinators. They are introduced just to go with the mathematical concept that root of a square plus b square must be somehow equal to a plus b. With the introduction of these operators, only they can then have a matrix representation, since these are independent of space and time coordinate. If these are dependent on space or time coordinate, the coordinates, they can have a integral representation or can have a differential representation or can have some position or coordinate dependent representation. However, these are not at all dependent on space or time coordinates, so they can never have a representation other than the matrix representation. And we have seen that anti-commutator alpha I alpha j equal to 2 times Kronecker ij. We represent this exactly in this way because of the fact that I can be different from j. So this has two different implications. What happens when I is different from j? When I is different from j, this is definitely equal to 0 because the Kronecker has only one meaning when I is different from j, that's equal to 0. When I is different from j explicitly, alpha I alpha j anti-commutator is equal to 0. When I is equal to j, then that means alpha I square equal to 1. Also, anti-commutator alpha k beta is equal to 0. And often a unification of alpha and beta, 3 alpha operators and 1 beta operator, is done with the introduction of a new operator, say gamma. So gamma is a new operator that is having 4 different components. The 4th component of gamma is necessarily exactly beta, and the first 3 components have the general format gamma mu equal to minus I beta alpha mu, where mu is varying from 1 to 3. The first 3 alpha operators are introduced here. So gamma 1 is equal to minus I beta alpha 1, gamma 2 equal to minus I beta alpha 2, and gamma 3 equal to minus I beta alpha 3, and gamma 4 is equal to beta itself. And using this operator gamma, we will be able to modify the Dirac equation in the covariant form, and that, or in the form of a covariant tensor, and that reduce or omit the difficulty of covariance. The unification of Dirac operators 3 alpha i's and beta in terms of gamma operator help us to represent the equation in covariant form as well, and that help us to get rid of the difficulty of discussing the Lorentz covariance of Dirac equation. For that, we will be representing the equation itself in the format of a covariant tensor. And for this, consider the Dirac equation IH cross dou psi by dou t equal to H cross E by I alpha I dou by dou xi plus beta mc square operating over psi. Multiplying this equation from left, that's what you call not from left but from right, that's what you call post multiply this equation by minus I beta. Then this becomes, we write the time dependent term to the right side and this operator on the left side. H cross E by I is already there. Alpha mu dou by dou x mu is to be multiplied by minus I beta, and beta will be commuting with all these space as well as time dependent operators. So H cross E by I into minus I beta alpha 1 dou by dou x1 plus H cross E by I minus I beta alpha 2. Actually, we are pre-multiplying it by minus I beta. So this into sign is say somewhere here and is not at here, this point. H cross E by I minus I beta alpha 2 dou by dou x2 plus H cross E by I minus I beta alpha 3 dou by dou x3 plus beta mc square is there, and we multiply it by minus I beta into beta mc square operating over psi equal to, on the right side we have IH cross dou psi by dou t, we multiply it by minus I beta IH cross dou psi by dou t. Now this is H cross C by I into minus I beta alpha I, that is the representation for gamma mu. So this is actually gamma 1 dou by dou x1, gamma 2 dou by dou x2. H cross C by I is a common factor, so we replace this by means of the index mu. H cross C by I gamma mu dou by dou x mu, where mu varies from 1 to 3, minus I into beta square mc square. Beta square is already identity, so this is minus I mc square operating over psi equal to, on the right side we have minus I square, make it say plus beta H cross dou psi by dou t. Now we take this term as say beta is there for, or there in this term, we make it say gamma 4. And we multiply this equation by I by H cross C to get around this coefficient H cross C by I. H cross C by I vanishes, what remains is gamma mu dou by dou x mu minus I mc square into I by H cross C, that is minus I by H cross C into I mc square operating over psi equal to I by H cross C into beta H cross dou psi by dou t, that is I beta H cross by H cross C dou psi by dou t. Of course, H cross will be vanishing and we will be taking this term to the left side. This becomes gamma mu dou by dou x mu minus I square is plus 1 mc square by c, make it say mc by H cross operating over psi equal to beta I by c dou psi by dou t. We take this term to the left side and this term to the right side, then this becomes gamma mu dou by dou x mu minus beta I by c dou psi by dou t equal to minus, this term is taken to the right side, minus mc by H cross psi, that is gamma mu dou by dou x mu beta is gamma 4 and we have minus I in the numerator, that is plus I in the denominator. So 1 by C dou psi by dou t, dou psi by dou it, and C is also there. Then we will write it say ICT together to make this as the fourth component of the space-time unified coordinate, or say the Minkowski space, fourth component or fourth coordinate of the 4 vector space. That's equal to minus MC by H cross C. Instead of this is actually psi. That is gamma mu dou by dou x mu plus gamma 4 dou by dou x4 equal to minus MC by H cross psi. Or we unify mu and the fourth component using this representation nu. Gamma nu dou by dou x nu, where nu varies from 0 to 3, such that when nu equal to 0, that corresponds to fourth component or the time dependent component dou by dou ICT, and value of nu from 1 to 3 corresponds to the mu values, that is the space dependent coordinates. So this is gamma nu dou by dou x nu, and this term is a constant MC by H cross, that is taken to the left side to make it say plus k operating over psi equal to 0. Clearly this is a covariant tensor, and this shows that the Dirac equation is invariant under Lorentz transformation, and this discusses the Lorentz invariance of the Dirac equation. Now we will conclude the various properties of Dirac matrices. We have already seen them. All these matrices are, all these operators are Hermitian operators. They are anti-commuting among themselves. Anti-commutator gamma mu gamma nu equal to 0 over anti-commutator alpha I alpha j equal to 0 over anti-commutator alpha I beta equal to 0. In all these cases, summation over the indices I is understood. Also, all these operators are idempotent operators. Alpha I square equal to beta square equal to gamma I square equal to identity. Once you account that they have only matrix representation, or is equal to 1. When this property is satisfied, there are a few supplementary properties. These are alpha I square minus identity equal to 0. That means alpha I plus identity into alpha I minus identity equal to 0. That means alpha I equal to plus or minus 1. For the eigenvalues of all these operators are plus or minus 1. And another property, trace of all these operators. This property is in fact a property come as an outcome of these two properties, number 2 and 3. And all these properties are nothing other than the properties exhibited by the Pauli spin matrices that you have already met while you talked about the angular momentum. Trace of alpha equal to trace of beta equal to trace of gamma equal to 0. All these operators are having a trace. Trace is nothing other than the sum of the diagonal elements of these operators, provided they are diagonalized. Or trace has the meaning of the fact that these are in fact the sum of the eigenvalues of these operators. And to prove this, consider the anti-commuting property. Anti-commutator alpha I beta equal to 0. That is alpha I beta plus beta alpha I equal to 0. That is alpha I beta equal to minus beta alpha I. And this is exactly the meaning of the anti-commuting nature of these two operators. Now we pre-multiply this equation by alpha I, then this becomes alpha I into alpha I square beta equal to minus beta alpha I is there, we pre-multiply it by alpha I, then this becomes minus alpha I beta alpha I. Alpha I square is identity, and we take the trace of this equation, trace of beta equal to minus is there on the right side, minus trace of alpha I beta alpha I. Now we apply anti-commutation property of beta alpha I. Beta alpha I is equal to minus alpha I beta. So this minus term and this replacement of beta alpha I by minus alpha I beta vanishes. What remains is trace of. There is no question of this minus sign right now. We will be replacing beta alpha I. Trace of alpha I into beta alpha I. So I have accounted the minus sign here also. Now we have an identity, trace AB equal to trace BA. So we take this as A and this as B. So trace of AB is equal to trace of BA. So beta alpha I into alpha I. So we have here it say minus trace of alpha I beta alpha I, that is alpha I beta. For that you take this as A, alpha I beta as A and alpha I as B. So AB is alpha I beta into alpha I. BA will be alpha I into alpha I beta. That is written here, alpha I into alpha I beta. Once again, alpha I square is here, which is equal to identity for 1. So this is minus trace of beta. So trace of beta equal to minus trace of beta. That means trace beta plus trace beta equal to 0. 2 times trace beta equal to 0 means trace beta equal to 0. That means trace of beta is vanishing. Similarly, by taking the anti-commuting property of alpha i's, replacing this by alpha I alpha j plus alpha j alpha I equal to 0, multiplying it by alpha I, you can prove that trace of alpha I equal to 0, and this property is exhibited by gamma mu also. Is in fact a property exhibited by all anti-commuting idempotent operators. Now combining these properties 3 and 4. So combining 2 and 3, you can produce property number 4. Combining 3 and 4, we must ascertain that they are having even order. And we have already seen that these operators can only have matrix representation, since these operators are independent of the space as well as time coordinates. And we have seen that their eigenvalues are either +1 or -1, and the trace is 0. Trace is necessarily the sum of the eigenvalues. Eigenvalue can have only 2 choices, either +1 or -1. Then there must be as many number of +1 eigenvalues as there are -1 eigenvalue. Then only the overall trace will be equal to 0. That means there must occur even number of diagonal elements. That means the order of these matrices will be an even number, either 2 or 4 or 6, etc. However, there is a theorem in group theory referred to as Provinious Theorem. The theorem states that in a group of members that are matrices, they cannot have an order greater than the number of entries in that group. These alpha and beta matrices, or the gamma matrices, or the Dirac operators form a group from these first 2 properties, I mean property number 2 and 3. And there are a total of 4 different operators. As long as the Dirac operators are concerned, they are forming a group from this abelian property, say anti-commuting, and from this idempotent property. And according to Provinious theorem, the order of these matrices will be then equal to 4, since it cannot be greater than 4, as there are 4 different members in this group. So the order of these matrices can be either 2 or 4. The order cannot be greater than 4 according to Provinious theorem. And an order 2 is not sufficient, because you cannot form 4 different matrices having order 2 and are satisfying these properties. You can form at most 3 different matrices having these 2 properties, property number 2 and 3. And these are nothing other than the whole spin matrices. So we are forced to take an order equal to 4 for this Dirac operators that cannot be greater than 4 according to Provinious Theorem, and according to Provinious Theorem that can be less than 4, and as per this property number 3 then it can be 2. However, there are no 4 different matrices having these properties and are having order 2. So they, and finally, since these matrices are anti-commuting, only one among them can be diagonalized at a time. So either you can take one among alpha or beta as a diagonal matrix in a representation, then all the remaining 3 must be non-diagonal matrices. Then we can formulate them to have a structure. In this representation, beta, that is equal to gamma 4, is taken as a diagonal matrix, and all the remaining are not diagonal matrices there. And gamma 4 has this representation I 0 0 minus I, where I is the identity matrix having order 2 or rank 2. This is for the method, or this is for organizing them easily. We will be representing these matrices that are actually 4 by 4 matrices using 4 2 by 2 matrices. This identity matrix is a 2 by 2 identity matrix, and this 0 is a 2 by 2 0 matrix. So that this is equal to 1 0 0 1 0 0 0 0 0 0 0 0 minus 1 0 0 minus 1, and alpha k equal to 0 sigma k 0, where sigma k is the polyspin matrix. So that this is actually alpha 1 equal to 0 sigma x 0, alpha 2 for alpha y equal to 0 sigma y 0, and alpha 3 for alpha z equal to 0 sigma z 0, and gamma mu then equal to minus I beta alpha k, that is minus I into beta matrix, this one into alpha k, that is 0 minus I sigma k 0. Now we'll see the continuity equation satisfied by Dirac equation. Since these matrices are 4 by 4 matrices, then psi will be a 4 component vector, 4 component column vector. That's what you call a spinor, as I have mentioned you earlier. This also necessitates psi to be a 4 component spinor. Now psi dagger psi equal to psi 1 square plus psi 2 square plus psi 3 square plus psi 4 square. That's a positive definite quantity. And now we define psi bar, the Dirac adjoint of psi, as psi dagger gamma 4. That's equal to psi dagger. Psi dagger is this one, psi 1 star, psi 2 star, psi 3 star, psi 4 star into gamma 4. That is identity 0 0 minus identity. Now we open this psi 1 star along this row and this column. So this is a 1 by 4 matrix, and this is a 4 by 4 matrix. Then once they are multiplied, you will make them as a 1 by 4 matrix, and this 1 by 4 matrix will be psi 1 star into 1 plus psi 2 star 0 plus psi 3 star 0 plus psi 4 star into 0, that is psi 1 star, first row first column entry. And the second entry will be psi 1 star 0 psi 2 star into 1, that is psi 2 star. Here this will be psi 3 star into minus 1, that is minus psi 3 star. This will be psi 4 star into minus 1 minus psi 4 star. And this is, say, psi bar is referred to as Dirac adjoint of psi. Now consider the Dirac equation in covariant form. Gamma mu dou by dou x mu mc plus mc by h cross psi equal to 0. Gamma mu is actually gamma k dou psi by dou xk, where k varies from 1 to 3, and gamma 4, that is the 0th component, gamma 4 dou psi by dou x4, operating over psi is written here. This bracket is opened and this gamma mu term is splitted into k and fourth component plus mc divided by h cross psi equal to 0. Now take the dagger of this equation, that is dagger of this one plus dagger of this one plus dagger of this one, that is gamma k dou psi by dou this is written as a nu, as I have mentioned it earlier in terms of say nu. So it is not k, it is here also it is nu, where nu varies from 1 to 3 and gamma 4 is written there. Actually I mentioned it as a mu. Anyway we make it say nu for the time being. Dou psi by dou x nu dagger plus gamma 4 dou psi by dou x4 dagger plus mc by h cross psi whole dagger equal to 0. Now AB whole dagger is B dagger A dagger. So this one dagger dou psi by dou x nu dagger into gamma nu dagger. Okay, we take it say k in terms of k, as we may make it confused in terms of mu and nu. As earlier I have used both mu and nu. So let's take it say in terms of k. So here also this is k, this is also k here. Since I have written it here mu corresponding to the 4 different components and I have splitted this in terms of nu. Earlier I have written it in terms of nu. So let me take it say in terms of k. Dou psi by dou xk whole dagger gamma k dagger, dou psi by dou x4 dagger gamma 4 dagger plus mc by h cross dagger is mc by h cross itself, since it's a constant psi dagger is written there. Now dou psi dagger by dou xk, because dagger has nothing to do with this space dependent operator which is purely real. But however psi dagger has a meaning. Gamma k dagger is gamma k, since gamma k is a Hermitian operator. And x4 involved the term ICT. When you take the dagger of this one, I is replaced by means of minus I. So this minus is written here. Dou psi dagger by dou x4 will be untouched then, as I have already taken this minus here. Gamma 4 dagger is gamma 4 itself. mc by h cross psi dagger, that's equal to 0. Now we post multiply this equation by gamma 4. Then this becomes dou psi dagger by dou xk gamma k gamma 4 minus dou psi dagger by dou x4 gamma 4 square plus mc by h cross psi dagger gamma 4 equal to 0. And then we replace this by means of the anti-commutation rule. Anti-commutator gamma k gamma 4 is 0. That is gamma k gamma 4 is minus gamma 4 gamma k. So minus is written here. Dou psi dagger by dou xk gamma 4 gamma k gamma 4 is altered as gamma 4 gamma k minus dou psi dagger by dou x4 gamma 4 square is gamma 4 into gamma 4. To make this term sure here, psi dagger gamma 4, which is the Dirac adjoint of psi, plus mc by h cross psi dagger gamma 4. This is also Dirac adjoint of psi. So we replace psi dagger gamma 4 by psi bar minus dou psi bar by dou xk gamma k minus dou psi bar by dou x4 gamma 4 plus mc by h cross psi bar equal to 0. That is minus dou psi bar by dou x mu gamma mu, combining these two terms, minus is also there, plus mc by h cross psi bar equal to 0. And this equation is referred to as Dirac adjoint equation. So to go with the continuity equation, earlier we have taken the equation and its complex conjugate, then multiplying these equations by psi and psi star. Here this is to be done in terms of the Dirac equation and its adjoint. Now what we have to do is that we multiply this equation by psi and the Dirac equation in covariant form by psi bar and subtracting them. That will give us a peculiar format. So pre-multiplying equation 1, that is Dirac equation by psi bar, and post-multiplying equation 2, that is Dirac adjoint equation which we have just seen in the earlier slide, by psi and subtracting them. Then we get psi bar. This is a pre-multiplication. Psi bar gamma k dou psi by dou xk. See, this is the Dirac equation. We pre-multiply this by psi bar, and this is the Dirac adjoint equation. We post-multiply this equation by psi and subtract them each other. Then we get psi bar gamma k dou psi by dou xk plus psi bar gamma 4 dou psi by dou x4 plus mc by h cross psi bar psi minus dou psi bar by dou x mu or minus dou psi bar by dou xk gamma k psi minus whole bracket is already mentioned here, minus dou psi bar by dou x4 gamma 4 psi plus mc by h cross psi bar psi. Then this becomes that step which I have just mentioned this here. Now this equation 4 involved pre-multiplication of Dirac equation by psi bar. Then this is psi bar gamma k dou psi by dou xk plus psi bar gamma 4 dou psi by dou x4 plus mc by h cross psi bar psi equal to 0. And post multiplying adjoint equation by psi minus dou psi bar by dou xk gamma k psi minus dou psi bar by dou x4 gamma 4 psi plus mc by h cross psi bar psi equal to 0. Now we subtract them. Then this becomes psi bar gamma k dou psi by dou xk minus dou psi bar by dou xk gamma k psi. So that makes it a plus dou psi bar by dou xk gamma k psi. Now this term minus this one, make this term plus psi bar gamma 4 dou psi by dou x4 plus dou psi bar by dou x4 gamma 4 psi. And these two terms are exactly identical. We vanish them upon subtraction. Or this is dou by dou xk of psi bar gamma k psi, that has combining these two terms. Here you will have to apply the product rule of differentiation. Pass function psi bar into derivative of this one. Gamma k is a space independent operator, so gamma k is taken out. Dou psi by dou xk plus derivative of first dou psi bar by dou xk into gamma k psi. So this is essentially dou by dou xk of psi bar gamma k psi, and combining similarly these two terms we make it say dou by dou x4 psi bar gamma 4 psi equal to 0. Or combining them in terms of the mu index, dou by dou x mu of psi bar gamma mu psi equal to 0. That means psi bar gamma mu psi is a conserved quantity with respect to the space-time coordinate. Again, we take this step dou by dou xk psi bar gamma k psi plus this term is dou by dou x4, that is dou by dou ict of psi bar gamma 4 psi equal to 0. Multiplying this by I into c, we obtain dou by dou xk ic psi bar gamma k psi plus ict is there in the denominator. Upon multiplication with ic, this purely becomes time dependent operator dou by dou t of psi bar gamma 4 psi. Now this is the three component divergence operation. Dou by dou x1 ic psi bar gamma 1 psi plus dou by dou x2 or dou by dou y ic gamma 4 ic psi bar gamma y or gamma 2 psi plus etc. That is del dot j plus dou by dou t of this quantity. So this is essentially the probability density, and this is the current density. Now the probability density or the position probability density, and this is the position current density. Then the position probability density is psi bar gamma 4 psi, that is psi bar is actually psi bar is psi dagger gamma 4 into gamma 4 psi. Gamma 4 into gamma 4 is identity, so this is equal to psi dagger psi. Psi dagger psi we have already seen, which is a positive definite quantity, psi1 square plus psi2 square plus psi3 square plus psi4 square. That is, the position probability density associated with the Dirac particle is positive definite, unlike the Klein-Gordon problem. With that, we close the first part of Dirac theory. Now we will have to talk about the success of Dirac theory.